There seems to be an unspoken rule in nature where major extinctions typically take their time, spreading their destruction over thousands or even millions of years. This is largely seen throughout Earth's history, with even the famous dinosaur extinction taking months or years to fully play out. In fact, it's actually quite hard to find a moment in Earth's past where everything died suddenly rather than gradually. However, there was one terrifying exception a very long time ago, as in before mammals even existed, where nature broke its own rules and decided to wipe out 99% of marine life in what might have been just a single day. This was the Great Dying, and it remains the fastest and deadliest extinction event our planet has ever witnessed. To understand this catastrophic event, let's first paint a picture of the world as it was 252 million years ago during the late Permian period. This was an Earth you wouldn't recognize. The continents we know today, like Asia, Africa, and the Americas, didn't even exist in their current form. Instead, nearly all the land was fused together into a massive supercontinent called Pangaea. Stretching across 1/3 of the planet, it was surrounded by a vast, endless ocean named Panthalassa, a sea so large it dwarfed today's Pacific Ocean. Even the day-to-day experience of time was different. The moon orbited closer to Earth, making days shorter, lasting just 22 hours. And life? It was harsh. On land, plants barely clung to existence in arid deserts, and the air was often suffocatingly hot. But the oceans? That's where life still thrived, or so it seemed. Dive beneath the waves of Panthalassa, and you'd find an alien world. This wasn't the vibrant ocean teeming with whales, dolphins, and coral reefs we imagine today. Instead, it was dominated by bizarre creatures that looked like something straight out of a sci-fi movie. The oceans were home to trilobites, small armored creatures that had survived for millions of years but were now struggling. Ammonites, spiral-shelled relatives of today's squids, floated through the water. Gigantic sharks, like the terrifying helicoprion with its circular saw-like jaw, had already vanished by this time, leaving behind smaller and less threatening relatives. Even the fearsome sea scorpions, once the apex predators of ancient seas, were barely hanging on, with only a few species left. But here's the twist. While life in the ocean was struggling to maintain balance, it still had its strongholds. Reefs built by sponges and algae provided havens for marine creatures. Fish darted through these underwater fortresses, while larger predators like early marine reptiles prowled the depths. This fragile ecosystem, however, was about to face a reckoning like no other. So, what could possibly kill off almost everything in the oceans in such a short span of time? To find the answer, we need to turn our gaze to the land, to a place now known as Siberia. Around 252 million years ago, this region experienced an unimaginable disaster. Massive volcanic eruptions began to rip through the Earth's crust, spewing lava and toxic gases into the atmosphere. These weren't ordinary eruptions. The Siberian traps, as geologists call them, were among the largest volcanic events in Earth's history. For thousands of years, rivers of molten rock covered an area larger than modern-day Europe, while thick plumes of carbon dioxide and methane poured into the air. The planet's temperature skyrocketed. Global warming wasn't happening over centuries. It was happening in real time. But the real danger lay beneath the waves. As the oceans absorbed the rising levels of carbon dioxide, the water turned acidic, a process known as ocean acidification. This spelled doom for marine creatures that relied on calcium carbonate for their shells and skeletons. Coral reefs, the backbone of the ocean's ecosystem, disintegrated almost overnight. The chain reaction had begun. As if acidifying oceans weren't enough, the volcanic eruptions also caused a severe depletion of oxygen in the water, a phenomenon called anoxia. Imagine diving into a sea where there's no oxygen to breathe. Fish suffocated en masse. Bottom-dwelling creatures like crabs, lobsters, and mollusks simply couldn't survive. Entire ecosystems collapsed, from the smallest plankton to the largest predators. And then there was the matter of toxic gases. Hydrogen sulfide, a deadly compound produced by bacteria in low oxygen environments, began to leak into the atmosphere and the oceans. This gas didn't just wipe out marine life, it also poisoned anything unlucky enough to be near the coast. The devastation was beyond comprehension. Oceans turned lifeless as 99% of marine species perished. Their once thriving ecosystems reduced to barren wastelands. Above water, the skies darkened with volcanic ash, and the Earth itself seemed to rebel against life. Massive underwater volcanic eruptions released immense quantities of carbon dioxide and methane into the atmosphere. This catastrophic injection of greenhouse gases caused global temperatures to spike. The oceans, unable to sustain their delicate balance, became oxygen deprived, a phenomenon known as anoxia. Entire food chains collapsed, leaving the planet teetering on the brink of total biological annihilation. But what was the true catalyst for this extinction-level event? To find the answer, we must look to the Siberian Traps, a vast region of volcanic activity. Roughly 252 million years ago, in what is now Siberia, one of the largest volcanic events in Earth's history began. Massive lava flows covered an area nearly 7 times the size of France. These eruptions lasted for hundreds of thousands of years, spewing toxic gases into the atmosphere and triggering a chain reaction of environmental disasters. The initial eruptions released immense amounts of sulfur dioxide, which formed acid rain and devastated plant life. But the real killer came from beneath the surface. Volcanic activity ignited massive coal deposits, releasing even more carbon dioxide and methane. This greenhouse gas explosion drove the planet into a superheated state, where temperatures rose by as much as 10 degrees Celsius, 18 degrees Fahrenheit. The oceans, already suffocating, became acidic, further compounding the crisis. Coral reefs, the rainforests of the sea, vanished entirely. It would take millions of years for them to recover. In the face of such apocalyptic conditions, it's hard to imagine anything surviving. Yet, a few resilient species managed to endure. Deep within the oceans, certain bacteria thrived in the anoxic conditions, paving the way for ecosystems to rebuild over millions of years. On land, burrowing creatures like ancestors of modern reptiles and mammals clung to survival by avoiding the scorching heat and toxic atmosphere. The recovery was painfully slow. It took nearly 10 million years for biodiversity to return to pre-extinction levels. This period of evolutionary rebirth gave rise to entirely new species, eventually leading to the dominance of dinosaurs during the Mesozoic era. The Permian Triassic extinction was a brutal reminder of how delicate Earth's balance can be. Today, scientists see troubling parallels in the rapid increase of greenhouse gases and climate change caused by human activity. While the scale and speed differ, the underlying mechanisms, rising temperatures, ocean acidification, and loss of biodiversity, are eerily similar. Understanding the past helps us prepare for the future. The story of the Great Dying is more than a tale of destruction. It's a warning about how fragile life is and how quickly it can change.